What is going on, Algebra 1? This video is going to help us identify how to graph how to identify any vertical shifts, horizontal shifts, or if there's a reflection, or even vertical stretches or horizontal stretches in our function based on our equation alone. So I'll show you what I'm talking about when we actually see the example. So here we go. So our final installation of this video set, we're going to graph y equals ax squared plus c, and specifically we're going to graph the equation y equals negative 3x squared plus 3, and we're going to compare it again with the parent function. So like before, I'm selecting my x's to be negative 4, negative 2, 0, 2, 4, and substituting those values into my equation. So I have negative 4 squared, you get 16, 4, 0, 4, and 16. I'm going to graph those points onto my coordinate plane. We can't graph negative 4, positive 16 because it's way too high, so I'm going to just imagine that there's a point way up there. But I can graph negative 2, 4, so I'm going to put that on the coordinate plane. And then I'm going to put 0, 0 on the coordinate plane, 2, 4, and I started connecting them apparently. So I have my 2, 4s right here, and I can't graph 4, 16 because it's way up there too. So I'm going to create my nice curve going from the vertex up to that point and draw an arrow knowing that it's going to continue to go past this point. Same thing on the other side. Now I'm going to use the same exact x points, negative 4, negative 2, 0, 2, 4, and figure out, well, what am I going to get for my y coordinates? So I'm going to show you how that works. So we are going to substitute in our negative 4 into our equation. So whatever we get here will be our y value. So negative 4 squared will end up being 16. Okay, so negative 3 times 16, we actually get negative 48 and then plus 3 still. So then we end up getting negative 45. Negative 45. And there's no way we can graph negative 45 when x is negative 4 because that's way down here. Okay, so notice how we're not actually going to be graphing up here, where our point is going to be way down here. So if you can kind of get an idea, little spoiler alert, where this graph or how this graph is going to shape. So we're going to do the same thing with negative 2. So when we have negative 2 squared, we get 4 times negative 3, we get negative 12 plus 3, we get negative 9. And if you're not sure of how I got this number, it's the same exact process as I did up here, except different numbers. Okay? So you can use your graphing calculator to get these values if you type this in your y equals function part. And then you can look up negative 2 and get negative 9, or mathematically do it by hand. So then I'm going to do the same thing with 0. I'm going to get 3. 2 is negative 9. When x is 4, I get negative 45. So I can actually graph, I'm going to put negative 9. I can't graph negative 45, or when x is negative 4, y is negative 45. There's no way I can do that. The negative 9 is not even on this coordinate plane, but I'm kind of going to imagine that I can do it, so I'm going to put the point way down here somewhere. So when x is negative 2, y is negative 9, so that's, I'm going to imagine negative 9 is right there. Okay, so then my next point's at 0, 3, so I'm going to put my point at 0, positive 3, which is way up here. Boom. And then on the other side, we have 2, negative 9, and then we can't graph 4, negative 45. So there's my curve, and if you look at it, notice how the graph is upside down. It looks a lot skinnier, which is narrower, and then it also looks like the vertex has shifted up 3 units. So visually we can see that it's skinnier, we can see that it's up 3 units, and we notice that it's reflected about the x-axis. Those are the 3 different transformations that I can pull from the graph, and if I look at the equation, I can tell that because my x squared is being multiplied by a positive 3, or I'm sorry, just a 3, a number that's bigger than 1, I'm going to have a vertical stretch, or a narrower narrower parabola, and that negative sign in front makes the graph flip or reflect about the x-axis. So we have the negative sign that makes it reflect, the 3, because it's greater than 1, it's not a fraction or a decimal, it's going to give us a vertical stretch, and that positive 3 at the very end has shifted our graph, our vertex, up 3 units. So those are the three different things that's being affected to the parent, or that's affecting the parent function. We have a negative 3. The negative sign's reflecting the graph. 3 is making it a vertical stretch, or having the graph have a vertical stretch or narrower shape. And the positive 3 is a shift in the positive direction for our vertex. So we would write that down. We have a graph that is reflected about the x-axis. It also has a vertical stretch and is shifted 3 units up. Okay? So obviously there are so many different examples that we can go through, but definitely make sure you take note of those different comments that I had about how the parent function is affected, to know if by just even looking at the function itself, if we have a shift vertically, or vertically, or if we have a horizontal or vertical stretch, or knowing when the parent function is reflected about the x-axis. Okay? That concludes the trilogy of 9.1a. So again, if you are watching this video, make sure you're listening to it, because just watching it's not going to cut it for you. Have a good night, guys.